This is the first of 3 lectures on process data representation and analysis. Basically, this is chapter 2 in the book. And this first lecture is going to be on linear interpolation, which we do a lot of in chemical engineering. So, linear interpolation applies when you have a table of data and you need a data point that's not on the table. So, let's say we have x1, y1 on the table, and we have x2, y2 on the table, but we don't have y and x. Okay, so what we have to do is we have to assume that the slope between y and y1 is the same as the slope between y1 and y2, which we have on the table. Okay, and this is a simple formula. It's just comparing the two slopes between y1 and y2 and the data point that you are looking for. Alright, so let's do an example calculation. Here's the steam tables, of which you will be using them a lot. So here we see the specific volume of steam at 10 kilopascals and 150 degrees C is 19,510 centimeters cubed per gram. So let's use linear interpolation to determine the specific volume of steam at 160 degrees and 10 kilopascals. Okay, so here's the 10 kilopascals. Okay, and now let's look at 160 is going to fall between 150 and 175. Okay, so we simply set up this relationship. Here is the two values of the specific volume at 175 and 150, which we can take right off the table. The one we don't know is at our desired pressure value of 160. So we just plug it into this equation, solve for y, and we get that y is equal to 19,970. So let's try an example. Okay, below are weight fractions of ethanol and water and the density of the mixture. Okay, so I want you to do this, and you can solve this problem on, if you go to Canvas, okay, I want you to type in the solution to this. Okay, it's going to be the video quiz 2.1. All right, so I want you to what is the density? Okay, we'll use this column here, actual data, for an 50% ethanol and water. And I want you to make this calculation by linear interpolation.